As the one propane appliance that's mostly out of sight and out of mind, the gas-fired water heater conveniently combines elements of two of the major systems found on motorhomes, the freshwater plumbing system and the propane system. Suffice it to say that since it's applicable to both of those major onboard systems, a variety of problems associated with either can pop up just in time to ruin a vacation trip. Though many safeguards protect both the plumbing and the propane portions of the water heater, a little proactive preventive maintenance by coach owners can all but eliminate some of the nuisance issues. Not counting tankless heaters, there are two major brands of RV water heaters, Suburban and Atwood. Let's take a closer look at a typical RV water heater. This one happens to be an Atwood model, but both brands operate in much the same manner. You'll likely have one or the other on your coach, but the maintenance principles outlined in this video are applicable to both. The vast majority of today's RV heaters will be electronic ignition models like this one, also called DSI or direct spark ignition models. Pilot models do exist, but there's probably not many around today. We truly appreciate just flipping a switch and having hot water appear at the faucets when needed. Roughing it? I think not. All electronically controlled heaters are equipped with a printed circuit board that manages all the operational duties, so the overall health of the 12-volt battery systems is also paramount. The board, positioned here on this heater, performs multiple functions. When there is a demand for propane heat, the board sends a signal to the gas valve to open, allowing fuel to flow to the burner. At the same time, it also creates the spark at the electrode assembly that ignites the gases as they enter the burner. Once the flame is ignited, it is monitored to be sure it stays lit. If the flame were to blow out for any reason, the board will close the gas valve automatically. Once the heater is filled with water, the entire 12-volt sequence is initiated when the on-off switch inside the coach is closed. Voltage is sent to a safety device called the energy cutoff, or ECO, which in turn sends voltage to the preset thermostat, which happens to be wired in series with the ECO, and then onto the printed circuit board where the board does its magic. Depending on the model, if the burner fails to ignite, the printed circuit board will try 2 or 3 times to make it work. If it continues to fail, the board goes into a lockout condition and the entire sequence needs to be reset. Reset the sequence by simply turning off the wall switch, waiting a half a minute or so, and then turning it back on again. Obviously, be sure you have sufficient battery voltage and propane in the container, and that the container valve is turned on. I mentioned earlier that the thermostat is preset. That also means it's non-adjustable. There's another video in this series that details how to install an adjustable thermostat on an Atwood water heater. If you have an Atwood, be sure to watch that other video. But only if you have an Atwood water heater. Suburban heaters do not have that option available. Of course, you can still watch the video if you want. Other components on this water heater include the gas valve located here, the orifice fitting and the mixing tube that leads to the burner area where the gas is ignited by the electrode assembly is positioned right here. I feel the electrode assembly is likely the most problematic component on the water heater. Since it's positioned directly in the fire and subjected to both high heat and high voltage, over time it can become covered with carbon buildup that might interfere with the necessary current flow, causing outages or other operational problems. Once or twice a year, use some 4/0 steel wool and clean the electrode probes like this. Just be careful not to bend the probes or to alter the spacing in between. Another problem can develop when the mixing tube becomes obstructed. All the campfire tales you've heard about spiders being attracted to the odorant in the propane are true. Here's a photo of a mixing tube totally blocked by a spider's nest. Periodically check to make sure there is nothing blocking the flow of fuel and air mixture getting to the main burner. Clean this tube when necessary. Another contentious point regarding this mixing tube is its alignment with the opening of the orifice fitting. It must be centered around the orifice opening and aligned in a straight line with the angle of the fitting as it exits the gas valve. On some models, the mixing tube might appear to be slanted, and that's okay as long as the alignment coincides with the angle of the orifice fitting. Also look straight down at the tube as it envelops the fitting. Be sure it's straight in all directions with that orifice fitting. Misalignment will cause the flame to burn back into the mixing tube. Perhaps you've heard a small pop or a mini explosion, as I call it. That's caused primarily by mispositioning of this mixing tube in its relationship to the orifice fitting. A related problem is an overly rich mixture or an oxygen-starved burner flame. Notice this adjustable shutter here. The default position is about 1/4 open. Loosen the screw and slide the shutter to achieve about a 1/4 opening. This is a very good starting point. When lit, the burner flame should appear mostly blue in color with maybe some yellow around the edges. It should also produce a slight roaring sound to a certain degree. If the flame appears lazy, floating, too orange, or you hear a sputtering sound like this, adjust the shutter to achieve a sharp blue burner flame. This shutter controls the amount of primary air that is drawn in by the force of the gas coming in through the orifice. All propane appliances burn a mixture of air and propane for proper and complete combustion. An improper mixture burning at the burner can cause sooting as well as carbon monoxide emissions. Not good. Periodically check the alignment, the shutter adjustment, and have the gas pressure checked at least once a year. This device right here is a safety thermal cutoff. On Atwood water heaters, it's designed to open the circuit controlling the ignition of the water heater if indeed there is a blockage in the mixing tube, creating a flashback flame that burns outside of the burner area. Also, be sure nothing is blocking this exhaust portion, and be very careful when the heater is in propane operation. This vent will get very hot. Once a year or so, blow compressed air into the burner tube here. Wear safety goggles, please, since dirt, soot, and debris will be blown out of the exhaust vent. Another maintenance task the proactive coach owner can perform is to drain and flush out the tank, thereby rinsing out all mineral deposits and other contaminants that settle to the bottom of the inner tank. Here's the drain plug on this Atwood water heater. On a Suburban, the drain plug incorporates its requisite anode rod, but on the Atwood, it's simply a plastic plug. By the way, there's no need for an anode rod in any Atwood water heater ever. Periodically drain and flush the water heater, especially if you experience an odor issue in the hot water. A hose attachment like this can be inserted into the drain plug opening to agitate and rinse the mineral deposits at the bottom of the tank. All RV water heaters will further be equipped with a safety pressure and temperature relief valve, the P&T valve, located right here. It will open if the pressure exceeds 150 psi or if the temperature exceeds 210 degrees Fahrenheit. Realize that it's completely normal for it to drip a little water during every heating cycle, the key phrase being a little water. Here's why. Whenever any liquid is heated, it will expand. Notice the air expansion pocket depicted in this diagram. There must be room above the water level in the tank for the water to expand into. After a period of heavy use, the oxygen portion of air above the water level is absorbed by the oxygen portion of the H2O. Same for the hydrogen component. Basically, the tank becomes plumb full over time, leaving no room for the water to expand into as it's being heated. That will cause the P&T valve to open up and expel the excess water as it's designed to do. So if you experience an abnormal amount of water being released during the operation of the water heater, it may be time to replenish that airspace in the tank. Here's how. First, turn off all sources of water flow and be sure the water heater is turned off and the tank has cooled. Then open a hot water faucet inside the coach. Typically, the closest one to the water heater will suffice. Then manually open the P&T valve, but stand back because water might just flow forth. Let it drain out of the P&T valve until it stops completely. Then close the P&T lever, close the faucet inside, and activate the fresh water supply, and you're good to go. You've successfully replenished the airspace above the water level inside the heater. So there you go, folks, just a few easy to perform preventive maintenance procedures that will not only keep your water heater performing, it will also likely eliminate most of those nuisance issues some RVers seem to go through every year. Keep in mind, this video does not contain everything you need to know about the water heater, nor have I mentioned every possible operational problem that can arise. We'll have to squeeze all of that info into a future episode. On behalf of FMCA, I thank you for watching, and I'll see you in the next installment of Motorhome House Calls.